All right, welcome everybody to our third ever fireside chat of the Vercel AI Accelerator. Today we have Erik with us, the founder of Modal.com. So Modal lets you scale out and deploy compute-intensive jobs, particularly like GPU-based stuff for AI and machine learning models. It handles all the infrastructure for you and can scale up in seconds and also scale down to zero when you don't use it. Super excited to have them here. They're an official partner of our Vercel AI Accelerator and have given folks a ton of credits. And Modal was actually mentioned a lot in our AI Accelerator applications for a lot of the people that are using it. So I know at least a couple of people from this cohort are using it. And without further ado, please take it away, Erik. Thanks for joining us.
Hi, thanks for having me. I have a couple of slides, and I thought I could also just write some code and do some like kind of a live demo. But real quick, just a super quick intro. I'm the founder of Modal. We founded it about 2.5 years ago, 3 years ago. And really like the sort of genesis was that I've been working with data for most of my career. I built a music recommendation system at Spotify in particular. So I spent 7 years there. At some point, I was the data team at Spotify, even though we didn't call it that. But I've done, started doing deep learning in 2014 and been doing a lot of large scale stuff and also some small scale stuff, business intelligence, data science, like building a lot of different things. And sort of my common observation was that data infrastructure is not quite where it should be. Like there's a lot of things that people want help with that is unnecessarily complicated. So I almost like started building a tool that I wanted to have myself, like kind of selfishly, like a tool I wish I'd had like throughout my career. And what that in particular, where I realized like the pain was the biggest was that was what I think of the runtime layer, meaning that at some point, if you're building a data intensive application, you need to run code somewhere in most cases. And that aspect of like taking Python, typically it's Python because data tends to be very Python driven, and like moving that to the cloud and executing that, especially when you want to scale out or schedule things or use GPUs or other types of things. That's kind of annoying. So I started building that, started realizing like I wanted to kind of essentially a serverless platform for doing that, that does that for you. See if I can. Any questions so far? How many people have used Modal in this group? By the way, I'm curious if is there like a hand raise functionality or like I'm just curious if I guess there's no.
Me.
Plus one. Nice. Okay, one person has used it. I'll love it. Good. Awesome. Plus two. Okay, so we got 2 people using it. 2 people. So I think probably like what makes most sense is I'll just like show you some stuff. And the way I usually do this is I like to keep it old school because I'm old. So I'm just gonna share my terminal screen and I'll just like run everything in there. Can you see my screen?
Yes.
Okay, sweet. So what is Modal? Conceptually, it's a function as a service platform. So similar to Lambda in that sense, like and architecture is quite similar too. Although we focus on very different types of use cases. And so it's very like sort of crude, description of Modal would be we take Python functions and we execute them in the cloud. And we do that in a way where it almost like feels like you're working with these locally. So here's a very silly function to just print some stuff to standard out, a standard error, and it turns the square of a number. Not too exciting, but and then we call it below here. But just kind of as a starting point, just wanted to show you like a very simple example. If you run this code, what happens is we take this code locally, move it to the cloud, execute it in the cloud in a container, and then as it's printing it, we stream the output back. And so what I always wanted to have, and when we built this tool that almost lets you retain the sort of the feedback loop that you have from like when you develop things locally, even though it's executed in the cloud, right? And as a developer, I always enjoy generally like writing code locally more because like I have this like fast feedback loop. So the question is like, how can we marry that with like the fact that you actually want to run stuff in the cloud, and that includes like editing code. Like if I rewrite some code and run it, I don't have to like build a container, push the container to the cloud, and go into some cloud console, trigger like a job, download logs, And by the way, this is like what you have to do with Lambda, right? Like if this feedback loop is like literally what you would have to do with AWS Lambda. It's like you have to build a container, push the container to the cloud, a container image, then go into console, trigger the job, download the logs. Like, so we have this like feedback loop where we can iterate things like very quickly. And that includes also slightly more complex things like building containers. Yeah, we should show this example. So there's like a marginally more complex example. And in this example, we define a custom image that uses scikit-learn, which is an old school traditional machine learning, and very, very great library, a lot of like great, like sort of classic methods. And here's a very simple example that basically fits a machine learning model inside a function. And this example shows a couple of things. Like one of the things is we can define a custom image, but the other thing is we can also scale out. So with Modal, you can take a function and you can map over it. And we handle sort of scaling up and down automatically. So in this case, we actually fit this model. We fit 99 different models, and we take the best hyperparameter. And so we run this thing. It will scale up as many containers as needed, and run them all in parallel. So you can see we run 21 containers here in parallel. Some of them run more than one function call, because we have this ability, like there's like bursty scalability. And by the way, like everything runs in like Modal's cloud in the sense that like we are a cloud provider, right? So like our business model is like we execute all the code for you, and then in the end, we charge you for the actual usage, right? So you don't use your existing AWS or GCP, whatever. Like you run the code inside Modal. We under the hood use the cloud providers, of course. Like we then use a bunch of different regions and cloud providers, and but we bill per essentially like nanosecond of CPU and GPU time. But a couple of things with this. Let's try to like install some other Python libraries. So let's say we want to install like NumPy and whatever, maybe like SciPy or something. We actually build these containers. Oh, sorry, I must have had this container cached actually. So I have to throw in some because we cache based on this combination. So maybe let's throw in Canvas.
Just a quick question for you, Erik, if you don't mind. What kind of hardware is this running on? Like, is this just running on traditional servers? Is this running on GPUs? And is that like a decision that your users make, or do you kind of make that?
You're like 2 minutes ahead of my live demo. I'll show you how to run this on a GPU. So
cool.
What I wanted to show first in this case was we build containers for you. So we build the containers in the cloud. As you saw, like we build containers very quickly. In this case, we installed a few new Python packages. You can do whatever you want. You can give us a Docker file, but we can also run commands. Like you can use like apt-get install or whatever, like install a bunch of binary dependencies. And we cache these container images in the cloud. We can build container images very quickly because in the cloud. So sort of handles all the like, you don't need Docker locally. Like in fact, we don't even use Docker. We built our own container builder. So I didn't mean to run this. You asked about GPU. Okay, so if you want to run stuff on a GPU, you can go and edit the function and say basically like I want to run this on an A100. So let's run this on an A100. You can see we're already fanning out and running.
Saying you have A100s right now?
We have a lot of A100s.
Are you saying you have A100s right now? Yeah.
We have a bunch of A100s. I feel like actually like now that everyone's the crazy like startups that are overfunded, like now that they're moving to H100s, I've noticed there's actually a little bit more A100 capacity in the cloud all of a sudden. Because I think they're all, now the new obsession is like H100s. So for us to like fine with, good old A100s, this might be a little bit more capacity actually. But as you saw, and I'll show this again. I mean, we basically like fanned this out and ran on 22 A100s in parallel. And we have this ability to like do like very bursty parallelism, like run a lot of containers on a lot of GPUs in parallel. The one that we have the most of is actually A10Gs. We tend to recommend A10Gs for inference in most cases. A100s are better for training. But A10Gs have basically the same performance for inference tasks. In this case, like this function doesn't even take advantage of the GPU, so it's kind of a silly example. But for a lot of use cases, there's obviously a very large difference, like moving from GPU to CPU. I can show you maybe a slightly, something more interesting, stable diffusion. Here's like actually a stable diffusion example. And let's just plug in, see what happens. We have an example of stable diffusion, which is one of our most common use cases. This is a bunch of people running different kinds of stable diffusion models. Spend a lot of time in general and just like cold start and like loading models very quickly. So this is the first time we're running it, but if we deploy this function and like run it consistently, like it'd actually be quite fast. It only takes like 5 to 10 seconds to start containers. But even with this, it's relatively fast. We took the code, we built a container, moved it to the cloud, and executed. And now we're running actually 5 different stable diffusion examples. And so if I open this, I guess I'll have to share. Yeah, it looks really weird actually. But in case you're curious, this is what it looks like. The output. I have no idea why this is Vercel Accelerator, but so some other cool stuff you can do in Modal is you can actually. Oh, geez, where did my terminal go? Oh, there it is. Sorry, go ahead. Was there a question? Okay.
Raju had a quick question in the chat, actually. He was asking what cloud provider you guys use to under the hood.
Oh, I see. Weird. The chat is like gone. The chat. I can answer the question, but I'm like nervous if other people are asking questions. Like I don't know how to see this chat. Actually, it's gone. We use mostly Oracle for GPUs, but we also use GCP and AWS. But that's like, again, like that's like kind of in a way like a black box from the point of view of the customer. Like the user interacts with Modal, and we fan out work to different cloud providers depending on availability and economics. Like there's the big considerations. You can so another cool thing is like in Modal, I can show you what this looks like. I mean, this is like a slightly more complicated example. What happened with this? Sorry, something is like my screen is like messed up. So this is like a slightly more complicated example. This is on our docs too, so I can send you a link and you can take a look. Like building the image is like slightly more complex, but it's not like super complex. There's the vanilla stable diffusion code is like nothing super complex. Any Modal app, you can deploy it. So you can take any code and just like create this like ephemeral or not ephemeral, like persistent function now deployed in Modal, and the cool thing is like now I can actually import this in Python. Let's see if this works. So it should be this. See if this works. Okay, run F. Okay, if we not call this thing prompt equals oops, sorry, I have to call this. I always forget this. This basically gives me a Python function or like an object that I can use just like a Python function and call this cloud function now that's deployed in Modal. And it would automatically do all the magic like spinning up containers and whatever. And it takes a little bit of time because we're generating 5 images. But the nice thing with Modal is like you can just create these like functions and call them from elsewhere. You can also create a web endpoint. So I can show you that in about 1 second. If you call this again, it'll be generally a bit faster because we keep the containers warm. So then of data, it just generate like this one actually returns like PNG. So it's not there's just like a PNG, but with open. You can actually save this. Let's try it. Yeah, I see an alligator, but luckily I don't know what happened to skateboard. There's no skateboard in there. Anyway, it's not super important. So as I mentioned, you can also create like web servers in Modal. So it's like a super simple web server. Like you can basically like in Modal say, I have a web endpoint. and it returns some data. So there's a very simple web endpoint that returns, renders a badge, like those like badges you see on GitHub. And you can run this ephemerally by just doing this. And now we actually get a public URL that you can go to that serves this app in the cloud. And if you edit the code, it like library loads. But you can also deploy this, and now you get a persistent URL that you can use that basically like serve these app like forever, right? So yeah, I mean, what else? There's a lot of other stuff. You can set up secrets. You can to import environment variables. You can set up schedules. You can set up like cron jobs. There's a way to like mount file systems to your containers. You can have like shared file systems. There's a lot of other cool stuff. And in terms of use, like just some examples of like stuff that people had built. I had this deck that I didn't really go through, but like some of the use cases, like for instance, we have this company that actually runs both like 3D rendering on Modal, but also like generates like 3D assets like through Modal. A company Musicify.lol that generates music, like they have some stable diffusion, not stable diffusion, some Gen AI models that generate music. Mage is like an aggregator of like different stable diffusion models. We have a couple of enterprise customers too. Like Scale does a lot of cool stuff. Ramp is another customer that does a bunch of stuff with Modal.
So fun fact, actually, Musicify is part of the AI Accelerator.
I forget.
I don't think he's here in this call, but yes.
Okay. Yeah, he didn't have to go to the call because he knows how to use Modal all day. Kind of, I don't know if this is like interesting to you, but like, how do we build this? Like Modal, like we spent like basically like 2 years like building our own orchestrator, building our own container builder engine, like building our own container runtime, our own file system. Like there's a lot of like custom stuff that went into the idea, like the ability to like launch containers in the cloud very quickly. And so we're not wrapping Kubernetes or, doing tricks like that. We actually went the hard route. But we think that the benefit of doing that is that we have a pretty solid competitive advantage in like this technical foundation that we built. Yeah, cool. I see now there's a couple of chat questions. So the goal of Modal is to be a general purpose platform. Yeah, I mean, I think like in a way, like I started this company almost like thinking like I want to build a better Kubernetes for data teams that's also cloud native, right? Like, and in the last like year or so, we've been focused very much like we've been very focused on like Gen AI because we felt like that's like a new space where people like clearly can't use Kubernetes. But like we have a lot of other customers too. Like we have people using us for computational biotech, 3D rendering, web scraping. There's a very wide range of stuff that people run on Modal. So there's a lot of stuff also outside, Gen AI and outside GPU stuff. So and that's always been the goal. Like we want to build a platform that you can use to build a very wide range of what I think was like data intensive applications. Yeah, cool. I went pretty quickly, so I don't know how much time. But I'll keep. If you want to ask me some questions, I probably have a little bit of time.
Yeah, let's get started with Q&A. Looks like Darlin has a question. Go ahead, man.
Hey, thanks for the walkthrough. I'm curious, can you decide what region Modal workloads run under? I guess my use case would be I would want to use something like potentially like Render just for basic web app type stuff, but maybe use this for obviously like running models.
Yeah, so my experience is like it kind of doesn't matter that much for that use case because like often like running models takes on the order of like a second or a couple of seconds. And so even like the round trip, like we actually started running some stuff in Europe recently, and the round trip from US to Europe is like on the order of like 50 milliseconds. So sorry, the one way. So round trip is about 100 milliseconds. So the marginal difference is not that much. But that being said, I think there are like a lot of good reasons why you might want to specify regions. So we are adding that capability pretty soon. Like one thing is often like if you have a lot of data and like you want to like, like you have data in an existing S3 bucket in one place of the world and you want to like make sure you run close to it, both from sort of a bandwidth point of view, but also like frankly like egress, like, it could be a cost issue. Like you want to move the compute to the data. So that's something we want to add support for pretty soon, the ability to specify regions, especially now that we actually, like under the hood, we're actually running stuff sometimes in US, sometimes in Europe. and in a couple of different places in Europe too.
Cool.
There's
Thank you.
different places in Europe, in the US. Yeah. Cool. And other things I can tell you about Modal.
Yeah, Alex, go ahead.
Yeah. Thanks, Erik. So I have a question. Can we set up a pool of nodes instantly on demand and for a very high kind of load of compute, and then bring them down whenever it's not needed?
So it auto scales automatically to the current load, to the current request volume, including scaling down to 0. There is a way to set up what we think of as we call it a warm pool, similar to Lambda. The main point of that is just to reduce cold start latency. If you have like uneven traffic patterns, you might want to keep some number of containers warm, just to handle like sudden spikes. If you want to have like low latency spikes. But generally, if you have like high throughput, like pretty consistently, you actually don't really need to do that, because we'll just auto scale to handle your request volume automatically, if that makes sense.
Yeah,
and we can scale up pretty quickly. Like if you want to, if you're asking for like 100 nodes, like we can get that like within usually a minute or less.
Yeah, I'm thinking that, for example, we want to make large scale. What we do as in Twitter is we make large scale code changes, right? So we want to pull up a bunch of nodes, like imagine that, I don't know, 100 nodes, do 1 million changes, and then we bring them down because we don't need that.
Yeah, no, totally. So that's exactly what Modal is built for, right? And what I think Modal is different is like with Modal, you don't create like instances. Like you just tell it like run this function, parallelize over this data, and we'll handle all the like how many nodes do you need and like what runs where, right? So, but we can auto scale like very, very quickly. I mean, I can like show you like going back to the example I had. Like we can try to like just take it a little bit further and see what happens. Let's try to scale it to 10,000 instead, just for fun, and see what happens. And run it on maybe 810Gs.
When you say 10,000, are you static? Is it the max, or are you actually making?
This is a list of 10,000 function calls. So now I'm basically like enqueuing 10,000 function calls, and we're I guess scikit-learn. There's some issue here. We'll probably have to just remove that code and like we can do something like this.
So I saw it spinning up containers as it went through. Is
Exactly.
that because it recognizes that, okay, there's 10,000 functions, I need to spin up more and more containers?
Exactly. Yeah. So now we're trying to do 10,000 function calls now in parallel, right? And so what's going to happen under the hood is it's now, oh geez, this is embarrassing. I'm not sure what happened here. Keyboard interrupt. Sorry, I need to return some. That's why. Return 5. So let's see how this works. So you can see how many containers it's spinning up, right? And so the idea is like we have 10,000 function calls we're trying to run here. And so if you see, we're actually spinning up more and more containers to handle 10,000 function calls. These are GPU containers, by the way. So now we're already running 60 GPUs. You can see the number keeps going up as we're processing these. Now we have 80 GPUs, 90, soon 100. Kind of curious. At some point, it probably like slow down a little bit, because we'll actually have to like go out and like provision new instances, which happens automatically. So if I look into our ops dashboard, probably right now there's like a big spike in like instances, but you can see like we can fan out and do this. We have this ability to like parallelize work over many instances. Does this answer the question or?
Absolutely. I want to know, what is the pricing work for this? Is it based on usage?
Yes. Yeah. It's all usage based. We charge for 810G specifically, we charge $110 per GPU hour.
Okay, that's great. And the final question is, how do you compare it with Lambda? When do we need to go with that, and when do we need to go with Modal?
I mean, I think Lambda, I want to say like use Modal for everything. I think Lambda, like I've used Lambda for a bit, right? Like I think the main thing that Lambda can do right now that Modal can't do is for pure CPU tasks. If you want to like parallelize the hell out of it, Lambda will let you start like millions of containers, right? Like Modal doesn't quite let you do that, right? And there's also a little bit lower latency in like starting containers. Like Lambda can serve requests a little bit faster. So for things that are just like very low level, like just doing like simple things, and if it's just Lambda doesn't have a GPU support, right?
Right.
So for stuff like that, I think there are places that Lambda does better than Modal, like, you know, simple things you want to just parallelize like millions of times. But as soon as you're doing stuff with GPU, as soon as you're doing stuff with that sort of compute intensive, or if you just want like a you know, normal developer experience, like I don't know how much you like I don't know like about you, but like every time I use Lambda, it's like banging my head against like AWS trying to get it to work. So with Modal, you have this like, you know, much better developer experience where you can just write the code and it just like parallelizes it and runs it in the cloud. I think that's really the biggest difference between what Modal and Lambda is.
Thank you so much. It was super helpful.
Yeah, cool. Awesome.
Appreciate that.
Great. Anybody have any other questions? In the meantime, actually, Sean shared some cool links in the chat that I actually want to pull up real quick. So he said that Modal can apparently access you can access storage. You can attach storage to Modal, which is actually really interesting because I've run into this problem before where I've used like Google Cloud Functions because I wanted to run some Python compute and I couldn't attach any storage. I just needed to save like a text file somewhere. I'd love to hear more about this and how it works.
Yeah, I mean, this is called Network File System. It's essentially like NFS. It's a wraparound NFS essentially. So you can mount these writable volumes to your functions, and then you can interact with it just like a local file system. This works great for a lot of stuff. It's not quite as fast. Like if you're like loading models, sometimes like performance isn't like amazing. So we're actually working on a much faster version right now that we hope to release in the next few weeks, which will have the ability to load, basically like have much higher read throughput, like on the order of like 10 gigabytes a second or something like that, which will actually make it useful also for things like model weights, which we found is a very common use case. Like people often want to create a storage bucket and then put a lot of different models on it. And then, you know, their functions then, you know, dynamically like want to load, you know, these the models. So network file system is the best we have right now. And it works great for a lot of use cases. It tends to be not super fast for like these like very like large throughput things. So that's why I'm like mentioning we're also working on an even faster file system pretty soon.
That's amazing. Wow. And then I saw Sean link this as well. The replace your own CEO with an LLM. I will definitely be checking this out. And then I also wanted to shout out Small Developer as well, which is something that Sean worked on that blew up over 10,000 stars now. And that runs on Modal as well. And it's kind of like your own junior developer, essentially. I don't know if you want to say any words about it, Sean. I don't want to put you on the spot.
I mean, it was my first introduction to Modal. And after building with it, I was like, I need to host everything with Modal. So it's been good. More coming.
Yeah.
Nice. Love that.
By the way, another thing we're actually experimenting with right now for speaking of this is an ability to run user code or like code from LLMs, like programming code in a sandbox environment. So the idea that like you can like define this like safe environment that you can like run like arbitrary code in and then like get the outputs, and which I think is maybe useful for stuff like this. I don't know if anyone in this group is working on like code generation, but we found actually like there's like a couple of like Gen AI projects around code generation, and they all need a safe, like a sandbox execution environment. So this is something we're experimenting with. Cool. Anything else I can tell you about Modal?
It's great.
Cool.
Yeah.
Sounds good.
Thanks again, man.
Awesome.
And thank you all for coming.
All right. Thank you. Feel free to ping me if you have any other questions. Awesome. Take care.